Welcome to a new episode of Sustainability Forward, our podcast. My name is Rishi. With me is my co-host Carmine, and we pick up today from our last episode where we introduced the 9 planetary boundaries framework, and we discussed 5 of those 9 planetary boundaries um, in quite a bit of detail in the last episode.
Yep.
Today, our aim would be to continue on the rest.
Yes. Great episode to continue the other one on these 9 planetary boundaries. So today we will talk about Biosphere, atmospheric aerosol landing, novel entities, and biochemical flows.
Yes, and the sixth boundary, to continue from our last episode that we want to start with, is biosphere integrity. That might sound complex, but it is essentially about the variety and abundance of life on Earth.
Yep. So let me try to help here in the definition. So there are 2 main components: genetic diversity and functional diversity. Now, think about genetic diversity as the variety of different genes found in a single species. Let's take an example. So, domestic dogs. Even though all dogs belong to the same species, so Canis lupus familiaris, there is a wide range of genetic diversity among them. This is why we have so many different breeds with varied size, colors, temperaments. Functional diversity refers to the variety of roles or functions that different species play within an ecosystem. Each species has a different, unique role. If it's a predator or pollinator, decomposer. So let's take a forest ecosystem, for example. You may have birds that eat insects, so the function is to be insect control. You have bees that pollinate flowers, so the function is pollination. You have trees that provide shelter and produce oxygen, so the function is habitat provision and oxygen production. So each of these species has a unique role or function in the forest. And the presence of many and different functions makes the forest ecosystem more resilient and balanced.
Yeah, great examples, Carmine. In summary, while genetic diversity looks at the variety within a single species, functional diversity looks at the variety of roles across different species in an ecosystem. And here's why it's crucial, right? High genetic and functional diversity allows ecosystems to adapt to changes, whether it is natural disturbances or human-induced shifts. But with activities like deforestation, pollution, overfishing, what we are noticing is a decline in biodiversity at an unprecedented rate. We are at high risk when looking at this boundary.
Yes, and this boundaries ecosystem, when you look at this boundary, you see a big red there. It's not just an environmental issue, it's a survival issue. Diverse ecosystem provide essential services like pollination of crops, decomposition of waste, and regulation of disease.
Absolutely, this boundary here it underscores the importance of halting and reversing the decline in biodiversity. Conservation efforts, sustainable agriculture practices, habitat restoration are among the many solutions that can help maintain biosphere integrity.
Yeah. Let's move to the next boundary. The 7th one is about atmospheric aerosol landing.
Yeah, and aerosols, as many of us might be aware, are tiny solid or liquid particles suspended in the atmosphere. Um, they can range in size from a few nanometers to several micrometers. So from really, really small to really small. Um, uh, there are, both sort of natural and anthropogenic sources when it comes to aerosols.
Yeah. So natural sources. So think about volcanoes, eruptions, dust storms, sea salt sprays, pollen, and organic compounds emitted by plants. And then you have anthropogenic source. And these include burning of fossil fuels, industrial processes, vehicle emissions, agricultural activities, and similar. The burning of biomass, for example, forest fires and agriculture burning, also releases large amounts of aerosol. So think about what happened last summers, for example, in North America.
Yeah. And why is this important? It's because aerosols end up influencing Earth's climate in multiple ways. So there is the direct effect, which is where some aerosols reflect sunlight back into the space, leading to a cooling effect. Others, like soot or black carbon, absorb sunlight and cause warming. So those are some direct effects. In terms of indirect effects, aerosols can act as cloud condensation nuclei, influencing cloud formation, cloud properties, and they can end up affecting rainfall patterns. This effect this can affect the Earth's energy balance as well as the hydrological cycle of the Earth. And essentially, more high concentration of certain aerosols, especially those coming from anthropogenic sources, can degrade air quality. Fine particulate matter, PM 2.5, can penetrate deep into the atmosphere and degrade air quality.
Yeah. So this planetary boundaries framework emphasizes the need to understand and manage the impact of aerosols on climate, human health, and ecosystem. So the good news here is that we are still operating in a kind of safety zone, but exceeding this boundary could lead to significant disruption in climate pattern and harm human health.
Yeah, absolutely. So let's take the eighth boundary in our overall framework of 9 boundaries, and this is the introduction of novel entities into our environment. And when we say novel entities, we are talking about new substances or new forms of existing substances that might get introduced in the Earth's system. And these can be synthetic chemicals, genetically modified organisms known as GMOs for short, nanomaterials, and more. While many of these have been beneficial for industrial and technological advancements, their unchecked release into the atmosphere can have adverse effects on the overall Earth system.
For example, chemical pollutants can contaminate water sources, harm aquatic life, and even enter our food chain.
Yeah, to name a few. And it's not just the immediate impact. Some of these chemicals persist in the environment for years, leading to long-term ecological and health issues. The boundary here, therefore, emphasizes the need for a precautionary approach, right? Understanding the potential impact of these entities before they become widespread.
Yeah. And the concept of introduction of novel entities, this boundary, emphasize the potential risk associated with releasing new or modified substances into the environment without a full understanding of their long-term impact. So this boundary highlights the need for precautionary approach, understanding the potential impacts of these entities before they become widespread.
Yeah. And so where are the solutions? The solutions lie in stricter regulations, right? Green chemistry that designs products to be less harmful, continuous monitoring of the environment for potential contaminants. So by being proactive and informed, we can ensure that our advancements do not come at the cost of our planet's health.
Yes. Now let's tackle the last but not the least boundary. So biochemical flows.
Yeah, this looks at the cycles of essential elements like nitrogen and phosphorus. These elements are vital for life, but can be disruptive when their natural cycles are significantly altered by human activities.
Yeah, it's not a simple one. Let me try to summarize it. So the use of synthetic fertilizers has greatly increased the amount of nitrogen and phosphorus entering the terrestrial and aquatic ecosystem. This has accelerated the natural cycle of this element. Think about industrial processes. Certain industrial activities release significant amount of nitrogen in the atmosphere. Wastewater discharge with untreated or poorly treated wastewater can be also a major source of nitrogen and phosphorus in the aquatic system.
Yeah, the effects of this boundary is currently in a risk zone, and it is now worrying. It's a major concern, because of eutrophication, soil acidification, biodiversity loss, which are all sort of major consequences that we might end up having if the boundary is exceeded.
So how we can mitigate it? Here there are a couple of examples. So sustainable agriculture or wastewater treatment. So for example, upgrading wastewater treatment facilities to effectively remove nitrogen and phosphorus before a discharge.
Yeah, and we need to manage and balance the input of essential nutrients such as nitrogen and phosphorus into the ecosystem to prevent their negative impacts. Avoiding causing of large scale ecological disruptions.
Yeah. So here we are. We discussed these 9 boundaries. Let's try now to summarize it, what we learned. We look at the planetary boundaries framework, so the scientific approach that identifies 9 critical processes that are essential for Earth stability and resilience. These boundaries are like the vital signs of our planet, indicating areas where human activities are pushing Earth beyond these limits. And on top, I was thinking, Richie, of our initial episode when we talk about the top challenges in face of sustainability. And actually, in that episode, we cover most of the content today. And that probably reinforces all our assumption. And I'm happy we are doing this episode today because we are going much deeper in these challenges.
Yes, Carmen, a great job sort of connecting it back to the challenges that we identified. So these things are nothing new, but this framework is a nice one because as we reflect on these boundaries, it's quite clear that our actions, both individual and collective, have profound impact on the planet. But it's not all doom and gloom. With knowledge comes the power to change, to innovate, and to find sustainable solutions.
Yeah. And while we saw a lot of red in this framework, and there was very little green, the planet boundaries is not just a warning, it's a roadmap. It shows us where we need to treat careful, where we need to pull back, where we need to push forward with sustainable innovation.
Absolutely. I thoroughly enjoyed that discussion, Carmine, and thank you, listeners, for tuning in.
I enjoyed as well. Thank you, Richie. Thank you all for listening.